All right, welcome back. In this video, we're going to talk about some linear inequalities. And so that's going to be like, graphs of linear equations, except they're going to be inequalities now. And you might remember this from Algebra 1. This is where we were, kind of graphing a line, and it might be dotted, it might be solid. We were shading maybe above, shading maybe below. So this should be pretty familiar. All right, so let's start off back kind of where we were last time, or the time before. We're going to graph the set of points x, y in the xy plane where y is equal to x plus 2. Hopefully this is, or we can sketch that graph. Hopefully this is not too hard. Maybe we can just say it's going to be like that. Okay, and I'm even going to label this y is equal to x plus 2. Okay, really want to emphasize that this line here is the places where y and x plus 2 are equal. Now let's think about graphing all of the points where y is less than x plus 2. And now I don't want us to overthink this, right? If we're thinking about where y is less, well, we know that down here are lesser values of y, so this is the area that we're talking about, right? All of these places, below the blue line, that's going to be where y is less, okay? But if we drew this picture kind of without the line, it would be really hard for us to express the idea of we're going to go all the way up to that blue line and not include it. So what we do is we make the blue line dashed when it's a strict inequality. I'm just going to kind of finish off doing my coloring over here. That's enough coloring. You see what I'm getting at. So in order to talk about all of these points here, where I might call this in yellow the set of all points where y is less than x plus 2, to show that we're going to get rid of that blue solid line and we're going to replace it with a dashed line, right? And you might remember that from a previous algebra class, that this means that we're not actually including the line. But if we wanted to talk about a region where, say, y was greater than or equal to, okay, well, we don't care about this yellow region, right? Because this yellow region is where y is less than x plus 2. So it stands to reason that the other side of the line, that's going to be the places where y is greater than x plus 2. Okay, so I'm going to clear out that, and I'm going to say, okay, well, greater than or equal to is going to be all of this area up here, right? But to indicate that it also includes the kind of the border, the boundary, we're going to use a solid line, right? We're not going to make a dashed line. And so I'm just going to finish in coloring this in. And then this would be a graph of all the points where y is greater than or equal to, right? The greater than is in gray and the equal to is in blue. So in conclusion, we're going to wrap this all together kind of with a thing that's in the red box, kind of some advice for ourselves, that we're going to use a solid line anytime it's a less than or equal to or a greater than or equal to. Okay. And the reason that is because we're interested in the equal to. So we're going to include the line. Right? Okay. We're going to use a dotted line anytime our inequality is strict, that's strictly less than, or that's strictly greater than. Okay. But what I would say about this is that, we don't say less than but not equal to, but that's what it means, right? It would sound too close to less than or equal to. We just say less than. But when we say less than, we mean not equal. Okay, so I'm going to just say that these are because it's not equal to. And in our previous example, that blue line that I had, that was where it was equal to. So that's why we use a dotted line to indicate that it's not equal to. And then shading above the line, well, that's going to be where y is greater than, some function of x, or y is greater than or equal to. Because we shade above when y is greater, because, up is where you see greater numbers on the y-axis. Okay? So the reason would be, well, y is greater. And then for less, or shading below, it's going to be less than or equal to, because for the same reasons. So y is less than, or maybe it's y is less than or equal to, but it's the less. Okay, and then that's kind of the reason there. So this, I feel like these 4 pieces of advice are really kind of like fully surrounding the graphing linear inequalities situation. All right, now let's put this into action. So I think that maybe I'll work the one on the left, and then I'll let you try it out on the ones on the right. Okay. So y is less than or equal to 10 minus x. That's the same as y is less than or equal to negative x plus 10. If you really want it to be in slope-intercept form, so that you know, okay, I'm going to start it, and then I'm going to have a slope of -1. Okay. Or maybe you know what the graph of y equals 10 minus x looks like. I don't know. But what I'm thinking here, as I'm looking at this problem, is that I'm seeing a less than or equal to, so I know it's going to be a solid line. And since I'm seeing less than, I know I'm going to shade below. So I'm just going to write that down before I even start to go graphing. So solid line and shade below. Okay. And then I'm going to, kind of sketch the graph of what I think y equals 10 minus x should look like, and I think it should look like that. Because evidently, this is going to be the point where y is 10, and this is going to be the point where x is 10, and that'll work. Okay. We'll just say that has a slope of -1. Okay. If it's a solid line and we're going to shade below, well, I know you don't need to spend a lot of time watching me shade, but I'll just shade in like this. And, if you don't have a highlighter, or, you don't feel like coloring in all of the space, you can just give me a couple of squiggles below the line. That'll be good enough, right? Because these don't have to be like the most perfect graphs in the world, at least not in my class. Okay, now I want you to try 6x minus 2y is less than 12 and x plus 3y is less than 9. Okay, my recommendation for these, so that we can kind of use that advice I gave you about shading above or below, is to just solve for y in the inequality. Solve for it, y inequality mx plus b, and that will really help you. You just need to remember, especially with this one here in the middle, that when we multiply both sides of an inequality by a negative number, it reverses the direction of the inequality. So you need to be aware of that. Okay, so I think maybe I'll walk you through that on the first one, because I don't know that we've actually needed to do that in this class yet. Multiply both sides of an inequality by a negative number. But if I'm trying to solve for y, I'm going to start by, in the middle, I'm going to start by subtracting 6x from both sides. So I'm going to actually start off with, that's on the shot. So 6x minus 2y is less than 12. Okay, now I'm going to subtract 6x from both sides. And now I'm going to want to divide both sides of this inequality by -2. And I know that anytime I multiply or divide, because division is multiplication, anytime I multiply or divide both sides of an inequality by a negative number, it's going to reverse the direction of the inequality. So when I multiply by -1/2 here, that's going to turn around the inequality. And now I'll have -6 divided by -2 is going to be positive 3x. And I got to be fair, I got to divide everything by -2, right? I can't just divide the y and the x by -2. I have to divide that 12 by -2 as well. And so I'll have 3x minus 6. Now, because I'm looking at I guess I'm going to do this one too. Because I'm looking at where y is strictly greater than, I know it's going to be a dotted line and it's going to be shaded above. So maybe I'll just go in and kind of do that. I don't know if this is even linear, but it's close. It looks pretty good. And well, we can shade up here where y is greater. And I'm over here, I'm not really worried too much about, did I go all the way to the dotted line? As long as you are clear about which side you are indicating is the solution region, you should be fine. And while I'm coloring, I think I already made this point, but when we're shading all of the coordinate pairs x and y that make that inequality true. So for example, if I talked about the point where x is 0 and y is 0, and I do 6x minus 2y, well, it's definitely going to be less than 12. And if I take this spot up here, you're like, wait, I can make y as big as I want, but well, that's because it's minus 2y. Say that's x equals 0 and y equals 10. Well, that would be 6 times 0 minus 2 times 10. Well, that'll be negative 20. Negative 20, definitely less than 12. So both of these pink dots are solutions to the inequality. Specifically, any of the points that are shaded in yellow will also be xy pairs that satisfy this inequality. 6x minus 2y is less than 12. Okay? Now, you try this next plus 3y is less than 9. Okay? I think that you should do that. You should try to solve for y on its own on one side of the inequality. Graph the thing, with the appropriately dotted or solid line, shade above or below. But you want to pause now because in just a few seconds the answer is going to pop up. All right, there you go. So I worked it around. I got it down to y equals negative 1/3 x plus 3. And so I graphed y equals negative 1/3 x plus 3 with a dotted line. And I shaded below because this is where y is less, right? Dotted because it's strictly less than, below because y is less. Okay? So that was a good set of 3 examples. I think past that, you'll just need to practice it on your own. Right, now let's work the backwards problem, right? Let's work the problem where it's like, hey, here's a graph of an inequality. Why don't you tell me what the inequality is, right? We just did the one where it's like, hey, here's an inequality. Why don't you give me a graph of it? Both of these are great for multiple choice, right? Here's an inequality. Which of these 4 choices of here's a graph. Which of these 4 choices of inequality represents the graph? Or the backwards. Here's an inequality. Which of these 4 graphs represents it? Okay, you can safely expect to see that on your unit test, right? So we're going to write an inequality that represents the graph below. All right. So in my mind, the first thing is to just figure out what is the equation of the line, and then determine is it going to be greater than or less than, or greater than or equal to, or less than or equal to from there. Okay, so I'm going to go up there, and I'm going to say, all right, I'm seeing a y-intercept of 1 right there, and a slope of 2. Let's see, are y'all able to see that? Yeah, you can see it went up 2 when it went over 1. So, I don't really need that. But I will say, all right, with an intercept of 1 and a slope of 2, that's the equation y equals 2x plus 1. But this whole region over here in purple, this is actually where y is going to be greater, right? Because I'm shaded above, and it's going to be greater because the line is dotted. So this is y is greater than 2x plus 1. And I've got another one. I figured I'd let you try that one on your own, see if you know what you. All right. So here's another one. I'd suggest that you try this one on your own, right? Pause the video, get yourself a hypothesis, write down an answer, and then check your answer against mine in about 5 seconds. It'll pop up. All right, there you go. So, it's going to be less than or equal to because I'm seeing a solid line and we're shaded below. Okay? And then I can tell that the equation of that line is y equals x plus 2 because it's got a y-intercept of 2 and a slope of 1. So I know that's going to be my inequality. So let's move on. Let's just look at some specific examples that, might help you work problems on the homework or the quiz or something. All right, this is a problem. Okay, they're going to say f of x is equal to 1/2 x plus 6. What values of x make f of x less than 0? Okay. Now, in the next few classes you're going to take, like in pre-cal or calculus, we're very interested in where functions are positive and negative for reasons that will become more apparent when you get there. Okay, for now, it's just that's why we're interested in solving inequalities. Today, we're solving linear inequalities. Later on, we'll solve quadratic inequalities, maybe even polynomial inequalities of higher degree later on in this course. So it's really to prepare you to do the exact same thing in calculus when solving the inequality has some meaning. Today, not going to have a lot of meaning. So we're going to figure out where this function goes negative, right? So I'm going to say, all right, well, we want f of x less than 0, and we have a formula for f of x, so I'm just going to plug in using that formula. So I'm going to say, all right, if they want f of x is less than 0, then they're really saying 1/2 x plus 6 is less than 0. And we'll be able to solve for the values of x using techniques from, the first lesson in this unit. So I'm going to start by subtracting 6 from both sides. So 6 minus 6 is 0, and then 0 minus 6, that's negative 6. Okay. And then I'm going to multiply both sides of this inequality by 2. And that's a positive number, so I don't need to worry about reversing the direction or anything. and that will be x is less than negative 12. And that's my solution. Okay. Now, what we would find is if we had graphed this, graph this line, y equals 1/2 x plus 6, and we looked at where the line itself was below the x-axis, well, it would have probably been at the x-axis at negative 12, and it would be below the x-axis before negative 12. That's what I'm saying, geometrically. Okay, but I don't think I'm going to draw you a picture here, because we've got other examples to do. Now it looks like we got an example talking about two different functions, and we're going to say, where is this function bigger than that function? Okay, we can do that. All right, I lost my place. I had someone walk in my room. Pardon me. Okay, so I'm thinking, okay, I'm just going to substitute on g of x and h of x, right? G is 2x plus 1. H is 3 minus x. I'm just going to set it up like that. I'm going to say, all right, well, 2x plus 1 is greater than or potentially equal to 3 minus x. Okay, and then I'm going to drop the color after that. I'm just going to work in gray. Okay, so I think I'm going to add an x to both sides of this equation. So I'm going to have 2x plus 1x is 3x plus 1 is greater than or equal to 3. And then I'm going to try to isolate 3x on that side by subtracting 1. So I'll have 3x over here, and then 3 minus 1. And now I'll divide both sides of this equation by 3, which isn't going to be a problem because 3 is a positive number, right? So I'll preserve the direction of my inequality, and I'll have x is greater than or potentially equal to 2/3. And this is the type of problem that we can solve, just provided that we've seen it once before, I think. Okay, now the last example I've got for you is kind of a contextual problem. Onions are costing 50 cents per pound, and peppers are costing $1.50 a pound. If you only have $10 to spend on onions and peppers, write a linear inequality for the combinations of onions and peppers that you can afford. Okay, this is another good use for standard form, right? We're going to write down an inequality, and it's just going to happen to be in standard form, right? Because if I think about my total cost, it's going to be the cost of the onions, which is 50 cents times the number of pounds. So I'll say, maybe I'll write this in pink. We have not designated which needs to be x and which needs to be y. That's a choice that we get to make. Okay, I'm just going to say x is going to be onions because we said it first, and y is going to be peppers. Okay. So the number of pounds of onions that I buy, that's going to be x. So it's going to be 0.50x plus 1.5, because that's $1.50, times y. Okay. We have $10. That needs to be less than or equal to 10. Okay. And that's a linear inequality, right? And it's in standard form. Make it really easy for us to find x and y intercepts, right? Okay, so for the x-intercept, I guess I'm just going to compute it down here. I didn't leave myself nearly enough room to work this example. The meaning of the x-intercept, I'll get there. The x-intercept itself, that's where y is equal to 0, and that should probably lead you to the meaning. So that's 0.5x plus 1.5 times 0, that's just going to be plus 0. Okay, so 0.5x plus 0 is less than or equal to 10. That's just the same as 0.5x is less than or equal to 10. And then x is less than or equal to 20. Okay, so if x is 20, then y is 0, which means that if I'm going to spend all of my money on onions and peppers, but I actually spend none of the money on peppers, I can afford 20 pounds of onions. Okay, and I'm going to just write that in there. And then I can do the same thing for the y-intercept. I'm realizing I haven't graphed this yet, but that's the easy part, right? We've had enough practice on that. The y-intercept, that's where x is equal to 0, and I really don't have much room there. So that would be where 1.5y is less than or equal to 10. And so y would be needing to be less than or equal to, well, 10 divided by 1.5. I think I'm going to have to pull up a calculator window here. So I'm going to do 10, and I'm going to divide by 1.5, and I'm going to get 6.667. Okay, so that's enough calculator there. and we'll say y is less than or equal to 6.67. Okay, which means that I can afford 6.67 pounds of peppers if I'm not buying any onions. Okay? But now that I've got my x-intercept of 20, my y-intercept of 6.67, well, I'm going to just kind of connect them. And then because it's y is less than or equal to, well, I know that this is the region that I'm interested in shading, right? Because out there, beyond the line to the right of it, it's going to be more expensive, right? It's going to cost us too much. We only have $10 to spend on onions and peppers. Okay, so that's it for this example. That's it for this video. Thanks for watching. You need to practice.